Okay, the first thing that I'm going to hand you today is going to look like this sheet I have projected here. And it's graphing rational functions using RADI, okay? It is on this obnoxiously bright pink paper. The reason for that is because it is so important. I need you to keep track of it. You cannot lose this, okay? This is something you need to have out with you anytime you are in class right now this week, working on homework, studying for your quiz on Friday, okay? All of this needs to be committed to memory. So yesterday what we did is we focused on graphing using transformations. Today we're going to focus on graphing using this process called RADI, and it's to help us kind of gather information. Okay. I'm going to go ahead and give you your notes page as well. But we're going to work our way through the RADI handout first.
Is the quiz on Friday going to be like Monday through Thursday?
Yes, the quiz on Friday focuses just on graphing.
Okay.
They'll ask for an extra.
Wait, is this, yeah, you gave them an extra.
Okay. Don't start talking. Don't start talking. Stay focused. Okay. So when we graph rational functions, we're going to go through this process using RADI. Okay? And each of these letters stands for something important that we need to do when we're graphing. And we're going to go through this process every time we graph a rational function. Okay? So the first thing we're going to look for are roots. And what are some other words for roots? Zeros, solutions, x-intercepts. Okay? And when will the y value of a rational function equal 0? A rational function is a polynomial over another polynomial. So when will you get that to equal 0? What would have to be true? When does a fraction equal 0? When the numerator is equal to 0. Okay, because 0 divided by any number is 0. So the way you solve for your roots is you set your numerator equal to 0. And then you write your answer as a point. Roots must always be given to me as a point. Okay? Your graph must pass through the roots, but they cannot pass the x-axis anywhere else besides your roots. You cannot just have your graph cross the x-axis because it looks right. You're only allowed to cross when there's a root. Okay, so in general, if I were to give you x minus 2 over something, it doesn't really matter, where would the root be of this graph? At 2. So at 2, your graph, your curve must pass through the x-axis. Okay? Okay. A stands for asymptotes, specifically our vertical asymptotes. And vertical asymptotes represent where the graph is undefined. What makes a fraction undefined? 0 in the denominator. So in order to figure out where our vertical asymptotes are, we set the denominator equal to 0 and solve. Any value that makes the denominator equal to 0, it makes the function undefined. Okay? So if I had a fraction, something on top, don't care what it is, but I had a factor of x minus 2 in the denominator, where would that create an asymptote? Okay, what would the equation be? X equals 2. These are vertical asymptotes. So at x equals 2, we'd have a vertical asymptote. In a situation like this, where it's just a single factor, vertical asymptotes will split your graph. And what that means is if the curve is going down on one side of the asymptote, it must be going up on the other side of the asymptote. So that would look something like this. Down on one side, which means over here it'd have to be going up. So in general, single factors in your denominator split your graph. Okay. This is so important because I'm going to break the rule of asymptotes in a minute. But in one thing that is absolutely positively certain, you may never, under any circumstances, no matter what, cross a vertical asymptote. Never, ever, ever. I don't care how bad you want to. Because the graph is actually undefined there. There is no way you can get a value for your graph at that point. No, because we can't divide by 0. And the vertical asymptotes exist at the x value that makes you divide by 0. So mathematically, you cannot do it. Okay? Really, really important. Never, 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 no way, no how, cross a vertical asymptote. Okay. The T stands for two things, tangent and together. And what that represents is if one of our factors in our numerator or our denominator is being squared. Okay, then something different is going to happen. If in the numerator we have a squared term or a squared factor, so let's say, for example, we had x minus 2 squared over something else. We don't care what. Okay? What is my root still in this expression? 2. But that root now has what we call a multiplicity of 2 because it's being squared. There's still only a root at 2, but the 2 has a multiplicity. And that is going to cause my graph to be tangent at 2. So here's what that looks like. At x equals 2, instead of coming up and passing through, your graph is tangent. So it hits at x equals 2 and bounces back down. That's what the tangent means. You hit the x-axis and you bounce down. And that happens when you have a factor with a multiplicity of 2 in the numerator. Okay. If you have a factor with a multiplicity of 2 in the denominator, what happens is called together or togetherness. Factors in the denominator create what? 0. That's in the numerator. Asymptotes. Okay, so if we had something, we don't care what, over x minus 2 squared, now we have a squared term in the denominator. We still have an asymptote there, though, where? 2. X equals 2. Always give it as an equation. We still have an asymptote at x equals 2. But I told you, when it's a single factor, the asymptote splits your graph. Okay? When the factor is being squared, your graph comes together at the asymptote. So if we're going down on one side, we're also going down on the other.
you're going down, not up.
The direction will come into play once we put all this together. All you need to know is that the arrows go in the same direction at these asymptotes. Okay? All right, flip it over. Okay. Rational graphs also have horizontal asymptotes most of the time. And the E stands for end behavior. And what this means is what is happening on the graph as x gets really, 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 really big and as x gets really, 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 really small. So as x goes towards positive infinity and towards negative infinity. The horizontal asymptotes guide what happens at the end. Okay? They decide what happens as towards positive infinity and towards negative infinity. So this end behavior is our horizontal asymptotes. Because horizontal asymptotes are in place to guide what happens at the very, very ends, okay? Really, really, really big and really, really, really small. That's their focus. In the middle, we don't really care about horizontal asymptotes. So, as weird as it is, one thing you have to learn is that you may cross a horizontal asymptote if needed. And what I mean by if needed is, say you needed to get to a root. You had to get to that root, but that root made you cross a horizontal asymptote. You still have to get there. In the middle, it's okay to cross a horizontal asymptote. Horizontal asymptotes are in place to tell us what happens way, 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 way positive and way, 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 way negative. That's why it's called end behavior. Okay? Okay. There's 3 categories of horizontal asymptotes. And each one is based off the degree of the top and of the bottom. Does anyone know what the degree of a polynomial is?
Isn't that the power that it's due?
Hmm?
Isn't that the power that it's due?
Yeah, so the degree of a polynomial is the highest power of a variable. Okay, so for example, if I had x cubed plus 7, what's the degree? 3. It's the power of your variable. Okay, so 3 cases. First case, if the degree of the numerator is higher than the degree of the denominator, there is no horizontal asymptote. If the degree of the numerator is higher than the degree of the denominator. So for example, if I had x cubed plus 7 over x, the degree of my numerator is higher than the degree of my denominator. What is the degree of my numerator? 3. What's the degree of my denominator? 1. So 3 is greater than 1. So there's no horizontal asymptote. Okay? If the degree of the numerator is less than the degree of the denominator, so if we had x minus 2 over x squared plus 7, what's the degree of the numerator? 1. What's the degree of the denominator? 2. Now the numerator is less than the denominator. So that's the equation y equals 0 for your horizontal asymptote. Okay? And lastly, your degrees might be the same. So if you had 3x squared plus 7 over x squared minus 5. How do I know the degrees are the same? Yeah, they're both 2's. They both have a degree of 2. So now you take the leading coefficient. What that means is the number attached to the variable with the highest power. So what's the leading coefficient in the numerator? 3. What's the leading coefficient in the denominator? 1. So your asymptote is y equals a over b. So y equals 3 over 1, which is just y equals 3. Okay? Couple different ways to remember the end behavior rules, whichever one makes sense to you. There's BOBO, which means if the degree is bigger on the bottom, it's O, y equals 0. Okay? If the degree is bigger on top, there's none. There's no horizontal asymptote. So Bobo and Botten, okay? This is the one that's kind of stuck in my head, but you can obviously use whichever one makes more sense to you. So high over low, the answer is no. High degree over low degree, there's no horizontal asymptote. Low over high, 0 equals y. Low degree over high degree, y equals 0. Degrees are the same, play the coefficient game. A over B. It's going to be totally your call which one makes more sense to you. Okay? Huh? 1. Y equals 1. Okay. Lastly is our y for radii, and we plug. It's called the y-intercept. And how do we always find a y-intercept? 0 for x, and write it as a point. Okay. Somewhere on this paper, so that you see it often, 2 things you need to always know. First, anytime you give me an asymptote, it must be an equation. Asymptotes must always be written as an equation. Roots and intercepts must always be written as an ordered pair. Asymptotes must always be written as equations, and roots and intercepts must always be written as an ordered pair. Intercepts. Okay. Second, and probably most important, these are rational functions. Every single graph you are asked to do will be a function, which means every graph must pass what? The vertical line test. Every time you graph one of these, you need to check, does this pass the vertical line test? If it does not pass the vertical line test, you've got to go back and try again. Something went wrong. Okay? That's a really great way to check yourself. Yes. Every graph will be a function. Yep, you must check with the vertical line test. Okay, so those are like your big picture special hints. Okay, you see why this paper is really, really important now? Yes. Okay? All right, let's give it a try, guys. Go to your notes page now, please.
Is the definition of a function where, like, where it passes the vertical line test or something?
Every x value pairs with only one y.
That's just the definition of it.
Okay, a rational function is a function comprised of a polynomial divided by another polynomial. Okay, we've reviewed this before. Or you could see it written as f of x over g of x. Big picture for a rational function is that you're going to have an x in the denominator, a variable in the denominator. Technically, some trivial cases of rational functions don't have them. But when we're talking about real thick rational functions, they've got an x in the denominator. All right, so for each example, we're going to work our way through radii. Okay? So we're going to start with y equals 5 over x minus 1. Okay, R stands for what? Roots. What does it tell us to do? Set the numerator equal to 0. So my numerator is 5. We set 5 equal to 0. Will 5 ever equal 0? No. So we don't leave it blank, though. We've got to write none. Is it okay to not have any roots, to not have any x-intercepts?
Yes.
Yeah, we saw that with our parent function. Okay, A, what does A represent? Okay, specifically vertical asymptote. And just while you're getting used to this, you might just kind of write VA for vertical asymptotes. How do we find our vertical asymptotes? Great. So our denominator is x minus 1. Set it equal to 0, and what does that give me? X equals 1. We need asymptotes as an equation. This is as an equation, so we're good.
Should we draw that in?
I like to gather all the information and then draw, but if you want to do it piece by piece, you can. Okay, T stands for togetherness and tangent. What you look for T, are there any squared factors?
No.
No. So we don't have to deal with T today, or right now. Okay, E stands for end behavior, and it means that we're really looking at our horizontal asymptotes. Okay, in order to determine our end behavior, we pay attention to the degree. So what is the degree of your numerator? No. 0. The degree of your numerator is 0, and I know that's tricky, but remember it's the degree of your highest variable. Okay, it's the highest degree of a variable. So the variable in essence in the numerator is to the 0 power because there is no variable. Okay, so the degree of the numerator is 0. What's the degree of the denominator? 1. Okay, low degree over high degree, low over high, 0 equals y. Okay. Y, what did y stand for? Y-intercept. How do we find the y-intercept? Okay, so we have 5 over 0 minus 1, which gives us negative 5. How am I going to write my y-intercept, though? Good. As a point with 0 in the x value and your y-intercept in the y value. Questions on any of those steps? Okay. Now we're going to start plotting. For me, it's easier if you are using multiple colors, which you definitely don't have to. But if you are, make your asymptotes one color, make your points and your curve another color. It'll help you see the difference. Okay? So I'm going to plot my horizontal asymptote and my vertical asymptote. Remember, when you plot your asymptotes, you need to use a dotted line, and you need to label each asymptote with the equation. After I plot my asymptote, I'm going to plot my y-intercept. And that's when I stop and think about what I'm doing. Tonight, your focus on your homework is getting to this point. Filling out radii and plotting your information on your graph. The shape of the curves you're going to get better at over the next few days. Okay, it's kind of weird at first. So right now we're just trying. Okay? Okay, so think about from your y-intercept here. Your horizontal asymptote, remember, controls what happens at the ends. So I know at the end of this graph, I have to be kind of trending towards my horizontal asymptote. So that's going to bring me down to my y-intercept. That horizontal asymptote's like a magnet. Okay? Now, from here, from my y-intercept, I have the option to go up or down. If I went up, do you notice that I would cross the x-axis? And remember, you are never, ever, ever allowed to create a root where there isn't one. right? You can only cross the x-axis where you have a root. Do we have a root over here? No. So I have to go down. Okay? Now, this graph, remember, has two parts. Rational functions have multiple parts. So this asymptote of x equals 1, it was not a together asymptote, right? It was not a squared factor. So instead, it splits our graph. So since we come down on this side, we have to be going up on this side. So that puts my second part of my curve in that quadrant. Yeah, the only points you have to plot exactly are your asymptotes and your intercepts. That's it. Everything else is just the shape of the curve.
And it has to look like similar to
I mean, I'm not saying that this is exactly where this is. This piece could be start up here. Okay? It's just kind of the general shape. Okay. Now, say you got to this graph and you forgot the rule that the asymptote splits your graph. Okay? You can always plug in a value and check. So I could plug in, say, 4. 4 minus 1 is 3. 5 divided by 3 is 5/3. But really what I care about is that it's positive. So at 4, I need to be in the positive part of my graph. And that would be another way to tell that this is where that part of the curve goes. Okay? You can always plug in points to give you more help. Okay? What is the domain of this graph? Good. What is the range of this graph? Questions about number 1? All right, let's go to number 2. Okay, on number 2, again, we're just going to work through the process. So we start with R. R stands for roots. How do I find my roots?
The numerator is 0.
Good. So x plus 2 equals 0. So x equals -2. But roots always have to be in what form? A point. So how do I write that? Good. Everyone okay with that? Okay. A is our vertical asymptote. How do I find that? Good. So x minus 1 equals 0, which gives us what? X equals 1. Everyone okay there? Okay. T. In T, we look for squared factors. Do I have any squared factors? So I have no tangent and no togetherness in this graph. Okay. E is our end behavior, which tells us we're thinking about our horizontal asymptotes. What do we have to compare to decide which case we have? The degrees. What is the degree of the numerator? 1, good, because it's x to the first. What's the degree of the denominator? 1. So we have the case where our degrees are the same. What does that tell us to do?
Play the coefficient game.
Play the game. All right. What is the leading coefficient of your numerator? 1. So if I'm calculating a over b, I'm going to have 1 over, what's the leading coefficient of my denominator? 1. So what does that tell me the equation of my horizontal asymptote is? Y equals 1. Great job. Everyone okay on that? Okay. Y stands for y-intercept. How do I find that?
0 for x.
Good. So 0 plus 2 over 0 minus 1. So I get negative 2. How do I write it, though? Good. Okay, questions about any of these steps? Okay, lots of people hard at work on the graph already. Let's go there. I'm going to plot my asymptotes first. Sorry, give me just a sec. Camtasia Convey is messing up for a minute. Sorry, give me just a sec. This is a great time for you to try graphing. Okay, so help me out because my information got erased. Where was our vertical asymptote? Okay, so remember, dotted lines and equations. Horizontal asymptote. Okay, did we have a root? Where was that? Good, and what about our y-intercept?
0, negative 2.
Great. Okay, so here we've got a single vertical asymptote, which means we've got gonna have two parts of our curves. One curve on either side of the horizontal of the vertical asymptote. Okay? Anytime you have 2 points in the same section created by the vertical asymptote, those must connect. Okay? They have to connect. Now, this root at negative 2, is that a tangent root? No, it was not from a squared term, which means at that root we go through the x-axis and then get guided by our horizontal asymptote. Yep, if this was x plus 2 squared, that would mean that we would have to bounce back down, but that wouldn't happen in this case unless we had another root somewhere or our asymptote was lower.
Okay.
So what you'll start to find is everything works together. You can't just create these like what-if scenarios because it changes a lot of stuff. Okay? Excuse me. All right. And then where am I going to have to go for my y-intercept? Yeah, you got to go down. Okay, this asymptote, is this a together asymptote or no?
No.
No. So it splits. There's no squared. So I'm down on the left, which means I have to be up on the right. What if you got stuck and you didn't remember that? Plug in a point. All right, what is the domain of this graph? Negative infinity to 1, union 1 to infinity. What's the range? The same thing. Good job. If you have trouble figuring out where another part of the curve goes, plug in a point to test. Okay, look at number 3. If you are given a rational function that is not fully factored, that is not in factored form, it's going to make your life a lot easier, and starting tomorrow, it's going to be required that you factor first. Okay? So starting now, you just want to always factor as much as possible when you're given an equation. Okay, so my numerator in this case would stay the same. How does my denominator factor? And what?
No, x minus 1 times x squared.
Yeah, that's what I thought. All right, x plus 5 and x minus 1. Everyone okay with that? Okay. R stands for roots. To find our roots, set the numerator equal to 0. So I get x equals -3. But how do I write a root? Good, as a point. Okay. A represents our vertical asymptotes. How many vertical asymptotes is this going to have? 2. There are 2 factors in the denominator, so I set them each equal to 0. So what are my 2 vertical asymptotes? Good. That means 2 vertical asymptotes are going to create 3 parts of the graph. 1, 2, 3. Okay? All right. T, look at each of your factors. Go to this factored form. Are any of those particular factors there being squared? No. E stands for end behavior, which is represented by our horizontal asymptotes. And to decide about our end behavior, you've got to check the degrees. What is the degree of my numerator? 1. What's the degree of my denominator? 2. Do y'all see that? Right here?
Wouldn't you count the one that you simplified them?
But it's easier to look at your degree from your original one because you're thinking about it being multiplied out. The highest degree, even here in the factors, is going to be x squared because you're going to multiply it back out. Okay? Yeah?
If you were just to look at the other one, would you is it 2 because 1 plus 1, like you're adding the 2 powers?
If you look at this factored form, the degree would be 2 because you know at some point you're going to multiply x times x, which is going to give you an x squared. Okay? All right, so low over high, 0 equals y, or y equals 0. Okay, y-intercept, what do? Okay, plug 0 in for x. In my opinion, using your unfactored form at the beginning is easier. So you're just going to have 0 plus 3 over 0 plus 0 minus 5, which gives us what? -3/5, and we write it as a point. 0, -3/5. All right, let's plot. Start with your asymptotes. Remember dotted line and equation. Okay, so what I was saying earlier is these 2 vertical asymptotes are going to create 3 parts of your graph. You're going to have something over here, you're going to have something in the middle, and then you're going to have something over here. Okay? Plot your intercepts. Okay, and do you notice that our 2 intercepts fall in the same section? So anytime 2 points fall in the same section, what must we do? Connect them.
Would that be considered the same? On the line?
Yeah, the sections are created by your vertical asymptotes. Okay? Now, it seems a little weird that we've got a root on our horizontal asymptote, right? But this is one of those cases where when you have to, you cross your horizontal asymptote. We've got to cross it. We've got to go through this x-intercept, okay? This x-intercept is not being squared. This is not x plus 3 squared. So I do not hit it and bounce down. I have to go through the x-axis there, and then the vertical asymptote acts as a magnet and pulls the graph towards it. All right?
How do you know that the graph doesn't go down from 0, negative 3/5?
I haven't finished yet. This is just the very beginning. Okay? So now I need to finish to the right of my y-intercept. If I went up, what would I create? Another root. And I'm not allowed to do that. So I have to go down from my y-intercept. So there's the middle section of our graph. Now we need to fill in the right section and the left section. Okay? And to do that, we're going to use our vertical asymptotes as a guide. Are either of these asymptotes together? Are they, any of them bring our graph together? No, because neither of them are being squared. So they split. So here I'm going up. So here I have to be going down. X equals 1 also splits my graph. So here I'm going down, which means here I have to be going up. Okay, let's talk about the domain. How many unions do you think we're going to have to use? 2 unions, because we're going to have to skip over -5, and we're going to have to skip over 1. So start at the very, very left. Negative infinity to what? -5. Union. -5 to 1. Union 1 to infinity. Okay. What about the range?
All real numbers.
All real numbers. Why?
Because that middle one
Yeah, that middle section
crosses the horizontal.
goes over our asymptote, which is where we would have skipped, but we had to cross it. So this is negative infinity to infinity. Okay? All right. One more. You guys are doing great. What should we do first? Factor. Good. So this is 6 over. How does that denominator factor? Yeah, so you'd get x minus 2 times x minus 2. And that tells us this is 6 over x minus 2 squared. So we're going to have to deal with that t at some point in this one, right? Because we've got a squared factor. But we'll wait till we get there. Start with your roots. What do you know? You set 6 equal to 0. Does that work? No? So what do we know about our roots? No roots. But remember, we don't just leave it blank. Okay, asymptote. Vertical asymptotes. How many vertical asymptotes does this function have? 1. Why not 2?
Because it's the same thing.
Yeah, if you set x minus 2 equal to 0, even if you do it twice, you're still going to get x equals 2. So our vertical asymptote is at x equals 2. Okay, and then for t, we check for squared terms. This time, do we have any?
Yes.
Yeah, on top or on bottom?
Bottom.
Okay, so on bottom deals with the asymptotes. So that means we do have a together asymptote. So we would write the graph goes together at the asymptote x equals 2. It's on the bottom. So if you look at your righty sheet, on the bottom talks about being together. What happens with the asymptotes? So we're on top, we would say it was tangent at the root. Okay, E. End behavior. Horizontal asymptote. Check your degrees. What's the degree of the numerator? 0. What's the degree of the denominator? 2. Bigger on bottom, y equals 0. Bobo. Okay. Y-intercept, plug in 0 for x. So we have 6 over 0 minus 0 plus 4. I get 3/2. How do I write that as a point? 0, 3/2. All right. Start by plotting your asymptotes. Now, let me show you. When I plot this vertical asymptote at x equals 2, I already know, because I gathered all my information, that this graph goes together at x equals 2. So what helps me is to label that some way. A T and circle it, or star it. Do something that when I am plotting my graph and I'm looking at my graph, that's a visual reminder. Hey, the graph has to go together here. The graph has to come together here. Okay? Horizontal at y equals 0. And a y-intercept at 0, 3/2. Okay, from my y-intercept, the only way I can go is where? Up towards my asymptote. And I gotta be pulled towards my horizontal asymptote. Because remember, if you have nothing else to guide you, your asymptotes are magnets. Okay, they pull the curve towards them. Okay, now we go together at x equals 2, which means we have to also be going up. All right, what is the domain of this function? Great. What is the range of this function? 0 to infinity. Okay, while you've got things out to write on, a couple hints and reminders about your homework. I'm going to hand you a half sheet with 8 functions on them for you to graph. Your homework is not from the book tonight. Okay, couple things I want you to remember. Every single graph must be what? A function. Every single graph must be a function, okay? I want you to focus on the radii information and plotting the points. The curve drawing is going to be hard at first, but it's going to get easier. Right now, you're focusing on the radii information and the points, okay? These graphs are going to look weird, and that's okay, okay? Be okay with that. Most importantly, guys, and I want you to hear this loud and clear, most importantly is that you try every single one. Plug in points, erase and start over. I would definitely be using a pencil, okay? I want you to try every single one. I will go ahead and tell you, I am looking at this tomorrow. Not for accuracy, it's your first try. I'm looking that everyone made the effort to try every single graph, okay? Jason.
Is the only time you cross over the horizontal asymptote when you have 2 vertical asymptotes?
No.